Welcome to this movie about paragraph 1.2 about the resultant. Or what force do you feel if two dogs pull you along? What do we have over here? We have a line, only it's a line for two dogs. As you can see, these two dogs, then you can then pull them along. And because it can twist over here, your lines won't get through each other. Excellent, isn't it? Well, I don't have two dogs, so that's not really the case for me. But we really want to demonstrate how to add forces or to how to draw or calculate a resultant with this example. Um, First of all, I've used a new word, the resultant. The resultant is the sum between brackets of all forces because you cannot simply add it. Sometimes you need to add, sometimes you need to subtract, and sometimes you need to draw. And it depends on the situation. And the resultant, we're going to write down F res for it. It could also be called the net force. But this is what we're going to use, FRES and resultant. Okay, and that's always two forces. What is the total effect of both forces? Well, there are three situations I want to discuss this. First of all, if you go to the same direction. Second, if it's in opposite direction. And thirdly, if any other way. First, if they're in the same direction. So right now, you can see Chris. This is Chris. Hi, Chris. He's strolling along. He has two dogs. So he gets out of his home. And yeah, social distance is not nice. So you need to get out. And dogs do that. You need to walk them. So Chris is walking around. And the first dog, it's a new one, and he is still pulling along with 30 newtons. He's very enthusiastic. And the old one, he's just scraping along. He just wants to follow it a bit, but at 10 newtons, that's what he does. And then what does Chris feel? Well, both dogs, they are in the same direction, so they help each other. So if you help each other, you can add the effect. So in the same direction, you need to add the forces. So resultant in the same direction, you need to add. So what do we have over here? We have the resultant is 10 newtons plus 30 newtons, and that is of course 40 newtons, and the 40 newtons is to the right. That is in the same direction. You need to add, just make this an A and an O, adds. And then the next one, if it's in an opposite direction. So here we have it in opposite direction. And Chris is sad. As you can see, he is sad. And, well, what will he feel? Well, one is working in one direction, the other one is working in the other direction. They're working against each other. So the 30 over here, and part is cancelled out by 20 and part is left. So we need to subtract. So opposite direction, subtract. Okay, so what do we have here for the resultant force? The resultant force is equal to 30 minus 20 is equal to 10 newtons to the right. Okay, that's now right now it's easy, and now the difficult part becomes What if it's a different, any other direction? Then you need a parallelogram, the parallelogram method. So we're going to use a parallelogram. And a parallelogram is not a science word or a physics word, it's a math word. And you can see in it, you can see the word parallel. Well, first of all, to give you an idea what is going on. Well, the dogs, they pull in this direction, that direction, and so then the total effect will be 30 in this direction and 20 in that direction, so it'll be somewhere over here. And you can see part there, and then something in this direction. How do you draw that exactly? And then this is called a construction. So you need to construct. This is how it's called with physics if you precisely draw to get your answer. Construct. And if needed, you need to draw the forces on scale. And as you can see, I have 30 newtons and 20 newtons with an angle of 62 degrees. Just to, if you want to follow me, do it by yourself, you can pause it and simply copy the situation and do my steps. Okay. We need to construct, we need to precisely draw, so we need a geo. So I am grabbing my geo. Here it is. And then the first step, real step, is to draw a line parallel to the point of a force, through a point of force and parallel to the other force. So I'm going to draw a line through, and I want to do it in another color than black, for instance in blue. I want to draw through this point over here, a line that goes parallel with the other. So that is this one over here. So I'm grabbing my geo and I'm holding my geo parallel with the other force, and then I make a, most of the time I make a dotted line like this. And now I need to repeat it with this one. So first I need to make sure my geo is parallel to that line, and for that we have these nifty lines on the geo. With the other one, both were horizontal, so it was a bit of bother, not really difficult to see, especially on dotted lines. But right now you can see there are here parallel lines, and right now the geo is parallel to this line because it's on it, and I can move it, and while I'm moving I want to make sure, well, the program does it, but if you do it in reality, you need to make sure that these lines, that they stay parallel. You can see that they stay parallel. And suddenly you are over here at the tip, at the pointy bit of the first other force, and then you need to make a parallel. Need to make another parallel line. And if you have done that, right now, you can see we have made a parallelogram, this figure over here. It has parallel sides, that is why it's called a parallelogram. And then you need to draw an arrow from tails from over here to the new intersection. So I'm grabbing my geo again, and I need to rotate it, where it is, there it is. And now, just to make it nice, I'm going to do a different color, green, yes, here we are. And this is my resultant, and the resultant is a force, so I need to give it a pointy bit. So this is the resultant. I have just constructed the resultant. And if people ask how big is this force, you simply need to measure the length As you can see, I have a length of 4.6 centimeters. So the resultant force is 4.6 centimeters. And the scale was 1 centimeter is 10 newtons. And that is, so it is 46 newtons. And you can see it is not added together. It is not 20 plus 30. Okay. What I want you to do to practice is to do this for yourself in your jotter, and I want to have two forces. Force 1 has 30 newtons as I had. Force 2 has 40 newtons, and they have an angle in between of 45 degrees. And of this, I want you to construct the resultant force. So please start drawing one force of 30 newtons and then a second force of 40 newtons at an angle of 45 degrees with the other one. So this one, yours should be on scale, is then 30 newtons. Mine is not. You should make sure it's on scale. And the other one is at 45 degrees. So this angle is then 45 degrees, and then it should be 40 newtons, so it should be on scale. Good luck with it, and we'll see you in class and starting we discuss this. Bye, see you around.